So I think I probably know almost half the room. My name is Eric Zemmer. I was one of the early Cloudera employees. I was at Cloudera from about 21 employees to about 800 employees, and recently left the mothership and started a new company called ScalingData. I'm not going to go in great depth with what ScalingData does. I'm going to talk much more about how we use Kafka, and unlike Gwen, I think, who gave you a bunch of really good options, I'm going to be really opinionated and highly specific and tell you all the things that you should not do with Kafka, and hopefully let you guys, hopefully you can learn something from that. So I'm definitely not going to talk about how Kafka works. I'm going to talk about sort of how we use it and how we stitch things together. And the goal is to kind of fill the spaces in between. So I think a lot of Kafka talks go into some hand-wavy stuff around, there are producers and they send data to Kafka, you know, hand wave, and then stuff happens, and then there are consumers that pull data out of Kafka, hand wave, and like data winds up in your systems and everything's fantastic. Unfortunately though, that winds up not being true, and I think Gwen actually got into a bunch of the hard parts, right? You get into data duplication and all these other kinds of things. So, you know, this is like the hand-wavy part. Producers into Kafka, Kafka into consumers, consumers into storage and or processing systems. What could possibly go wrong? So this is a list of stuff that can go wrong. So to start with, you know, getting data in, and Gwen just gave a bunch of really good examples, but you have these, you know, are they APIs? Are there legacy data sources like files on disk, or tailing files, or files and directories that need to be parsed? And I agree with Gwen that everything has structure. Saying things are unstructured means that it's just a bunch of bytes and nobody knows what to do with a bunch of bytes. The message schema thing I'm going to get into, things like keys and data duplication, partitioning, offset management. Where does transformation go, or where should transformation go for doing like inline transformation? What do you do with dead letters? So traditional, like, you know, for those of us who are, you know, used to like traditional enterprise, like ESB type stuff, there's always that case that somebody sends you bunk data, and when you get a bunk message that can't be parsed, what do you do with it? How do you handle that? So there's a concept called dead letter queues, or where you sort of take data that's malformed and you shove it into a place for later inspection by a human, or alerting. Durability to target systems. Again, Gwen just talked a whole bunch about this. Things like data center replication. So at LinkedIn, you know, and within the Kafka community, there's a project called Mirror Maker that will mirror topics and brokers. The problem is that people, in my experience, also want to do things like filter and throttle and rate limit and do all this other kind of stuff. So you might have 8 data centers and you want to aggregate all data of a particular type, and you might have, you know, heterogeneous event types or message types on the queue, and so on and so forth. So there's all this sort of space in between the, you know, that triplet of, you know, producer to Kafka, Kafka to consumer, and consumer to storage and processing. These things aren't Kafka's responsibility. So people say, like, well, why doesn't Kafka do that? And it's because Kafka does what it does very, very well. And this stuff is stuff that needs to be dealt with outside of the system. You wouldn't want a system that sort of tries to handle all this for you. And the problem is that all of these different things just, you know, depend on lots and lots of different stuff. So latency, requirements, batching, the types of storage systems, whether you have things like atomic commits and like all this other kind of stuff, and how you know, the shape of your data and how you want to deal with things, whether or not duplication is a problem or something you worry about. You need to think about them, even if Kafka doesn't. So I think that, you know, the team at LinkedIn, you know, Jay included, you know, these are people that studied like distributed systems and data management and transaction logs. The reality is the majority of the world is not like that. And that's something that I learned in my time at Cloudera. So for most people, you want it to just work for your use case, and like there's a bunch of details that you might not want to spend your time on, but, you know, at the end of the day, nothing is free. There's no magical technology where like data like magically shows up and only shows up once, and transactions aren't a thing, and so on and so forth. So ScalingData has two main pieces to its product. One is a data infrastructure that's built on top of all the open source components like HDFS and Kafka and Solr and Spark and so on. And then an application that does magic whiz-bang stuff that I'm not going to talk about. But what I wanted to give you is a very concrete idea about what the underlying, quote-unquote data platform is. The short version is that ScalingData, and I probably shouldn't say this on camera yet because we're in stealth mode, but who cares? ScalingData is largely building a system that is very, very similar, if not, identical to the use cases that Splunk targets today, but on top of like big scale infrastructure. So a lot of the use cases of machine metrics and IT diagnostics and syslog and like all this kind of stuff, we're very much building a system that pulls in all that data, does all the right stuff, and then presents it back to IT people to manage these big distributed systems. So for us, and I'm going to sort of step through our data infrastructure a little bit just to give you an idea about where Kafka fits in and how we use it. So we deal very much with what I'll call legacy data. So syslog, files on disk, that can't be changed. So we work with like financial institutions that go like, look, it's a trading system. It writes metrics to a file once every second, and no, you can't change it. And no, I'm not going to instrument my application with your APIs. So you need to find a way to get that data into your system, which is totally legit. So we deal a lot with this legacy data, and we are subject to quite a bit of auditing because we have to pull in this data, but we also need to live on the machines where this data lives. So for us, we needed to fit within, basically our customer said, you have about 5 megs of RAM. Your agent needs to fit in, and you need to take no more than like, 1% CPU off of one core. That's what you get on a box. So we wound up having to write an agent native code. And for us, we cheated a little bit. Joe talked about the client APIs that are available. We wound up using the Go APIs so we can compile down to machine code and be able to deploy statically linked binaries. The Go APIs are mostly good. I can tell you from production use. So if you are a Go shop, they're pretty fantastic, at least on the producer side, which is where we use them. So our agent acts as a syslog server that people forward data to, and we get data from syslog. We are starting to add a statsd port. So basically anything that speaks statsd metrics. For those of you who aren't familiar with statsd, it's worth looking up. You can just fire statsd messages at us. As well as things like that snarf machine metrics like I/O time, service time, and like all these kinds of things that you would scrape out of proc on a Linux box and squirrel those away into the agent. We can do that, and files and directories. What we actually do is, to Gwen's point, the schema thing was a huge problem for us, and we needed a way to transmit data in a single format that could be talked about and described that was structured enough for us to know what to do with, and I'll tell you how that works. Files and directories come in, and we do some parsing on the agent, and we create what we call events. And events are just an Avro object, and they don't include the schema, because Gwen's right. Squirreling the schema inside of the payload is a terrible idea. So what we actually do is we pre-share the Avro schema with both our producers, our agent, Java API, and a REST API, and our consumers. And that schema actually doesn't change, and I'll show you how we get around some of the schema evolution problems. We have log4j appenders and all this other stuff. But this stuff all generates event data, which is, I think I can show you the schema. Yeah, so this is what our event schema looks like. We have a timestamp that's always epoch. So internally, we always talk about epoch. We have an event type ID, which is effectively the class of the event. You can think about it as a giant switch statement at the receiving end. So this is how we get around the structured versus like unstructured problem. So basically, if you give us a timestamp, a type that tells us how to interpret the body, which is a byte array, and a bunch of key value pairs, this type acts as a class downstream. So this is how we dodge the whole problem of what is the schema of data moving across Kafka. It's always the same. And all of our consumers that are then responsible for getting data into downstream systems know and understand the schema. In reality, if we needed to evolve it, we can. It's just an Avro schema. We can add fields, and there's some evolution rules you have to obey, but we can do this today. This also opens up the door for, we can have built-in event types in our system that are completely opaque. So if somebody's building a new system and you're like a data platform team, we say that if you receive an event type, type ID 1, then just take that event and store it on disk. Don't bother looking at the body, don't bother looking at the attributes. We just take that data in and deal with it later. So this allows people to send completely arbitrary data. Our source field looks like an Amazon ARN, if anybody's used Amazon. So it's basically, for us, it's physical location, host name or IP address, service group, like web servers or load balancer group A or something like that, and then the service, which is like Nginx or HTTPD or something like that. So we have this sort of strong set of 4 dimensions that we use for things like filtering and grouping and all this other good stuff. And the attributes are just key value pairs. So whatever you want to give us, you can give us. And that's the format of the events topic. And we actually, what we tried to do is create what is equivalent to like a Twitter fire hose for your data center. So this one event topic contains heterogeneous events as they move through the system. And if you're interested in a particular type of event, you can build a custom subscriber and latch onto that topic and then just filter for all event types that you're interested in. And that gives you a full tap. So for security applications that are interested in, login events from a web application or SSH failed events that have a specific event type, you can steal those off of this one queue. You don't have to worry about schemas, and you don't have to worry about which topic that data is on. And if people add new applications, it sort of magically shows up in this topic. That, for us, this is one of the things that's very interesting about having lots and lots of partitions on a single topic. Our data rates today are somewhere between 1 to 10 terabytes an hour, depending on the customer. So that's what we do today, through some number of Kafka brokers that winds up being different for different people. Yeah?
Quick question. So if I'm just interested in one particular class of event, actually have to be calling events and do something with the consumer side?
Right. So the question is, if you're interested in just one type of events, one type of event, do you have to read everything? And in this case, the answer is yes, by default. We support the ability to take events, filter them, and shove them back onto another topic. So like if you want to, you can do that. And we do that in a couple cases. So we basically take an event off, and then if it matches a certain pattern, we shove it onto a separate topic that's lower bandwidth. The downside to that is you're trading latency for processing time. You know the drill. So for us, we ship, and I should have mentioned it before, the parts that are colored in blue here are the parts of our system. The other parts are open source projects that we don't really touch or muck with. So this event schema, and we expose this. We actually don't try and hide our schemas from customers and things like that. So when they want to build custom subscribers, we let them do that. We do include what we call our HDFS consumer and our Solr consumer. And those consumers are sort of like what Gwen described with the Flume case, where you have like a sink that deals with like the conversion from that event type over here to a storage or processing system specific type on the other side. I'm going to talk about the guts of that in a second, because that's where like a lot of the durability sort of fanciness happens. But those systems in turn write to their constituent, processing and storage systems. And we actually have started adding streaming support today. We're currently using Spark streaming, but I'm this close to ripping it out of the system in favor of anything else. Because of, I want to be really clear here. I think that Spark is a fantastic system. Spark streaming is a whole different animal, and it's just not there yet in terms of production quality. And again, I'm coming at this not from having an engineering team of 10 PhDs. I have to build software and ship it to Fortune 500s where it just works. And once you start getting into like auto commits that aren't bound to when you write to disk and like all sorts of craziness, and it stops just working, I can't ship it. I also can't ship Scala code when the bytecode changes with every freaking release. So don't even get me started. You didn't start me, I started me, but it's all the same to me. So at the far right-hand side here, there's the magic scaling data application, which I'm not going to get into during this talk because I'm not a sales guy. But the application itself is like multi-engine aware. So we basically take data in and we use Spark and we use Impala and/or Hive, depending on the version of Hadoop and like what features are available. Query HDFS for like trending reports and all sorts of other magic stuff. And then we use Solr for like your typical faceted full text search, like show me all events where the word error appeared. By the way, that's not a useful query in any data center. It's all, you want like a classic case of like a hard to decipher like series of log events. And our test case, we take the Kafka broker logs and Zookeeper logs and shove them into our own system. And if you can't figure out what's going on, we're not solving a real problem. So this is sort of what our system looks like. What I'm saying is it's complicated stuff, right? So this is our system and sort of how we use things. And I'm talking really fast, mostly because I'm born and raised in New York, and also because I want to answer questions if you guys have them. But so we've done this, and I got to tell you, having this sort of shared, having this well-defined schema allows us to make our consumers and producers dead simple. And any new application automatically knows how to deal with data, already knows how to deal with stuff. This is the inside of our consumers. And we had to jump through some hoops because we needed the ability to manage offsets in a very fine-grained manner. Because we're primarily dealing with HDFS semantics where files aren't durable until you close them and yada, yada, yada. And Eric, what about append? And no, not really, because we're writing columnar formats and all sorts of other good stuff. So this is the inside of our HDFS consumer. We also have the ability to, as data arrives, transform that data. And sometimes it's simply mask this field for compliance purposes, like take a credit card number and drop it. Only take event type 100, or do some field level mapping or something rewriting, or change the time zone, or whatever the case may be. So as we basically have multiple threads, each thread has an instance of the actual Kafka consumer class, which gives us a dedicated connection to Kafka, and this has to deal with like the way commits, or the commit is. We didn't want to use like the super low-level API, so instead we cheated and used the high-level API, but used one connection per thread because we don't really care, and I know that Jay and team are working on making the APIs better. So we punted for now. This kicks out our event class, which is a generated Avro type. We shove it through this sort of library of transformation functions, which are basically take A, produce B, and we sort of churn through a bunch of transforms. We always spit out Avro objects in memory, and from this point up is the same in all of our consumers. And even customers who want to build custom consumers can use this code. It's all just library code. It's this last piece that makes it specific to HDFS or Solr or whatever the case may be. So this Avro object that comes out, in the case of HDFS, we use the Kite APIs. If you're not familiar with Kite, it's a project that I started at Cloudera that I'm very excited about. So Kite takes this data and writes it to HDFS and deals with partitioning and metadata management and all sorts of other cool features. And you can configure Kite to spit out either Parquet or Avro. So this is where we vary the type of underlying storage. And if you configure it in such a way, it updates partition information in Hive so that if this automatically creates a new partition, Hive becomes aware of that partition, so like magic just kind of happens throughout the system. We also need the ability to deal with things like Kerberos, so we deal with that for strong authentication. And we needed the ability to write data sets as different users. So pretty common is that you would have multiple subscribers that are pulling a copy of the data and writing a cleansed version for, without personally identifiable information in one data set for, marketing, but in the security data set, all of the original information is still present, but it's restricted to a particular group. So we needed to be able to sort of deal with low-level HDFS permission controls and all this other stuff. So that's why we're able to read from multiple topics, but also write to multiple data sets. And I can go into whatever amount of depth. How am I on time?
You're good.
I'm good? So I'm probably out of time. Joe tells me I'm not, so I'm very excited. So we'll fit in some questions, and this is a subliminal message. Does any of this make sense? Does anybody have questions about any of this stuff? Yeah.
This is mostly a stupid question, just things that we have struggled with ourselves. Since you're Apple wrapper, like you said, you are probably not going to evolve anyways. And it has a byte array payload. In terms of serialization, does it involve a lot more like byte array copying? If you do it that way, then just depend some fixed headers or something like that?
That's a great question. So the question is the overhead of using a serialization library like Avro sort of significant if we're doing byte array copies and things like that as part of the serialization? There is some amount, whenever you're serializing from type A to type B, you're inherently doing some kind of copy, right? Because it's effectively different bytes. So yes, but you always have to have some kind of encoding. And for me, even though I jump up and down and I scream and I yell and I tell my developers the schema will never change, inevitably I will be so wrong and it will need to change. And again, this is for people building internal systems, enterprise software winds up being pretty different. Rolling upgrades and backward compatibility and all those kinds of things are not secondary, they're first class features. And if you don't have them, the other guy wins. So for us, I can defeat that overhead by telling the customer they need 4 machines rather than 3, and that basically what I'm telling the customer is it's $20,000 CapEx to buy 1 extra machine, or $40,000 2 extra machines, and a $3,000 a year OpEx to run that machine or whatever it winds up being. That price tag is significantly better than the system will be down for the next 8 hours while I upgrade you. And they're more than happy to take that load. For us, again, we're doing 10 terabytes an hour of data with 3 Kafka brokers and an end-to-end latency, which is the metric we really measure, from the time it's produced to the time it's queryable, and it returns in a Solr query around 400 to 500 milliseconds. So we're not going to be doing high-frequency trading, but we're certainly not Hadoop MapReduce jobs. And that's a pretty good margin, for most of our operations folks. Yep.
Is it Solr Cloud or is it Elasticsearch?
It's absolutely 100% Solr Cloud. And I have a whole diatribe about why it's Solr versus Elasticsearch.
Okay.
Elasticsearch is fantastic technology, but reinventing your own consensus protocol and being really susceptible to split brain and then throwing away a bunch of documents is a really, really weird side effect, right? So it's hard. Distributed systems are hard. That should be the closing slide in every presentation.
No, the first rule of distributed systems is don't distribute systems.
Right, don't write distributed systems, yeah.
My quick question when you are talking about that if you want to do filtering, you have to read those messages you have passed away, right?
Right.
Recently on the mailing list, there was a small note that Kafka together those topics. Someone asked to me whether it's there forever. So my question for you is, would hierarchical topics actually have to use case?
What kind of topic? Sorry.
Hierarchical. You can say I have a topic that are all my messages. I
Oh.
have a subtopic that is
Subtopics?
is X.
I think we're perfectly fine to have the notion of subtopics. The problem is once you push that in. Sorry, the question was if you're trying to filter out a particular event type, rather than read through all of the data as it's streaming into the consumer, ideally you'd only ever receive the event types that you're interested in. You would sort of declare that someplace. And the notion of subtopics that are views on top of other topics, for lack of a better description, would potentially give you this. The problem with that is you're pushing knowledge of the payload into the broker. And then you get into the cases, and Alan's nodding, so I know I'm right. So the problem with that is that you're pushing user code into the inside of the system, and then when inevitably you need to update those rules, now you're doing hot deployments, and like you have all these like weird side effects of like, do you deploy the same code across all 3 replicas of the same topic, and you get into weird synchronization cases, and it's way too complex than just saying buy an extra box and it just works, right? So like I think at the end of the day, the answer is keeping it really, really simple from somebody who has to debug a distributed system like by proxy, like on the phone, like what does the log say? Like it's really, really hard to figure out, have you tried grep? Like it's just terrible. Yeah.
Yeah, so are you updating the Solr indexes in real time from Kafka? And did you modify the MapReduce indexer? And if you did, can you open source it?
So a couple of things, and I'll answer them in variable order just to keep you guessing. One is ScalingData is building an application. Having spent 4 years at Cloudera building nothing but infrastructure, I don't want to maintain infrastructure for the sake of infrastructure. So anything we touch that touches the actual infrastructure, we have to contribute, because I don't want to be on the hook for maintaining it. That's what you guys are for. It's not true, I have to maintain it. The other problem is, so in the case of what do we do to feed data into Solr, our consumer does micro-batching, where it basically pulls out a bunch of events and shoves them into a Solr document list. There's no MapReduce in there. It's just direct.
Doing a REST call and just hitting it.
It's doing a REST. Yeah, excuse me. It's just doing a REST call to shove data into Solr. Yeah.
On the topic of schema versioning, so this is kind of a good idea, bad idea question. I have no idea. I don't know. Is using a topic per schema version with like maybe an agent to translate a migration strategy? Like we've been batting this around.
Yeah.
I don't know if it's really a good idea.
So the question is like,
if you don't have a
So you're all answer at the same time.
So the question is, if you have multiple versions of a schema, do you do something, like use one version of schema per topic and try and manage it that way? I think in reality, if you're asking yourself questions of versioning, step 1, stop inventing serialization protocols and use Avro, Protobuf, Thrift, whatever, and have like sane evolution rules. I would not do that because the topics in Kafka aren't free. Like your ordering guarantees are per partition, like there's all sorts of side effects that come from that. And for each topic, for each partition, there are log files, and you're basically taking what might be sequential I/O, writing to one topic, potentially like one or smaller number of partitions that might line up with disks, and turning it into effectively random I/Os. Like the more files you add that rests on the same physical devices, you're actually permuting the I/O operations, right?
running multiple topics.
Well, right. So if you have multiple topics being served from one broker, they turn into multiple log files, like under the hood, which means that there are multiple file descriptors, which means the disk head, is no longer Now I'm fudging a little bit because like you always have multiple partitions per disk. You're just turning that into a much bigger number, which potentially changes the semantics of reads and writes.
Wouldn't the page cache centric design of Kafka mitigate some of that?
So does the page cache centric design? Yeah, it does until the consumer falls far enough behind that it can't read from page cache. So like Kafka is really good in the case where your consumers and producers are roughly moving at the same speed. But if you get a case where consumers disappear, and the classic case is, something terrible happens to HDFS, or something terrible happens to Solr, and you've got like 3 hours of downtime, and all of a sudden it comes back, and all those consumers go like, give me everything from 3 hours ago, and like, your page cache starts flopping. Terrible things. I think, am I out of time? I don't know. Nope, I'm good. Bring it. It's really intimidating to talk about Kafka in front of the guy who wrote it. But also, and I don't know how many people know it, but I was one of the original developers on Flume. So this is really weird.